Hello everyone, this is Dr. Vinay Kumar, Associate Professor, Mechanical Engineering Department, College Tulsiramji Gaikwad Patil College of Engineering and Technology. Today I am going to teach you a new subject that is mechanics of material. It is also sometimes called mechanics of solid, strength of material. And today I am going to cover the concept of stresses and strain. Okay, so these are the topics I am going to be covered. That is introduction of stress strain diagram. If it is possible in this video, I will try to finish it. Otherwise, one more video I will take for you. Elasticity, plasticity, Hooke's law, shear strain, load stresses, limit, axial forces, and deflection of the body, and also torsion. Okay, so before I am going to start this stress strain, so first I will explain you uh, about engineering mechanics. So in engineering mechanics, we study about the rigid body. What is rigid body? Rigid body is a body when we apply some force, it is not to be deformed. It means what? It doesn't change its shape and size when we apply a force. So if I'll give a one example to you, wall, if I'll hit a wall directly on it, it doesn't deform because it has a more strength as compared to my hand. But if I'm using the hammer and try to hit the wall may deform because the hammer is more harder or rigid as compared to wall. So what is the rigid body? Rigid body is a body which does not deform under the action of load. Or I can say that it doesn't change shape and size under the action of load. But when it comes to the subject mechanics of material, we study about the deformable body. It means when we apply force, the body deform. It means the body change its shape and size. Shape and size means what? Shape and size means if it has a dimension of if length is 10, height is 20, and the width is some 10. So when I am going to pull this, so the dimension will be changed. Now come to the the topic, that is stress strain. Stress is what when we taking a one sub object, when we apply a compressive force, the length of the component will be decreased and the width of the component will be increases. Compression force means here if I'm going to apply a force, this object is going to be compressed, so the length will be decreased. But when I consider the tensile force, when I consider the bar, I'm going to apply a tensile force. It elongate and the length will be increased and the width and the height will be decreased. So these are the basics difference between the compression force and the tensile forces. Stress, if I'm going to take one more example, if I'm going to put my finger on here, if my finger across and passes through this body throughout, it means if it is there is no resistance force will be there, it means stresses is zero here. But right now, if you see over here, if I'm going to apply a one force on it, in this area, you will see that the my another hand will have a some resisting force. So due to this, we have a one mathematical formula that is stress, that is force upon area. Sometimes the it is also called force means resisting force upon area, or sometimes it is also called force upon resisting area. The unit for stress is Newton per meter square. Sometimes it is also called Pascal. So we will see that the tensile compressive are called direct. To whatever the force we are going to acting on the component, that is called tensile and compressive force. That is also known as direct forces. Most of the engineering field, we can go for kilopascal, megapascal, and gigapascal. So these are the basics of the stress. So we will go for the next. That is what direct strain. When we apply a force on a object, tensile force, when we apply a tensile force on it, the length of the object will be increased and the other dimension will be decreased. So when we apply a, for example, if I'm considering a one bar, that is a 100 mm length. If I'm going to pull it, the length of the bar will be increased, just like 105 mm. So the total elongation on the bar will be 5 mm. In engineering, we usually change these forces into stress and the deformation into stress. We defined this as follows. Strain is what? It is a load. It is change in length upon original length. It is called as epsilon. We can mostly indicate strain is epsilon. And we'll see that the strain is no unit since it is a ratio of original length to length. Most of the engineering material do not stretch very much before they become damaged. So strain values are very small figure. It is quite normal to change small numbers into the exponent for 10 to the power minus 6 microstrains. For example, if I am considering this mobile, if I am going to apply a one force on it, so the length of this mobile will increase. For example, here. So this much of elongation is called deformation length, change in length here to here. This length increased, but the original length is this. That is what? Strain. Modulus of elasticity. This is very important. So when we apply, when we, for example, for this, we will take a one example of rubber band. We will apply our force on it, then it definitely deform. It means deform means the shape and size of the wire will be changed. So what we can do, stress is directly proportional to strain. Stress is what? Stress is this, that's load upon area. Strain is what? Change in length upon original area. So in elastic material, when we apply a force and then we release that force, it comes to the original position. So elastic material always spring back into shape when released. They are also obey the Hooke's law. Hooke's law means stress is directly proportional to strain. This is law of spring that states that the deformation is directly proportional to the force. The stiffness is also depend on the various materials and various sizes. We may eliminate the size by using stress and strain instead of force and deflection. So if we already discussed about the stress equal to force upon area. So force equal to sigma into A and X is change in length equal to epsilon is strain L for actual length. So we can go for next PPT. Next slide. The stiffness is what? Stiffness is what? It is the ratio of stress to strain. That is what? Modulus of elasticity. The stiffness is now in terms of stress strain only. This constant is called modulus of elasticity. I already explained that stress is directly proportional to strain in the elasticity up to the elastic limit or Hooke's law. So as we know that the stress is directly proportional to strain, when we remove that is remove proportionality limit, we add always a one constant that is capital, that is elastic. A graph of stress against strain will be straight line with a gradient of E. This of E is say the same unit of stress. Ultimate tensile strength. If a material is stretched until it breaks, the tensile stress has reached the absolute limit, and this level is called the ultimate tensile strength. This is a stress strain diagram I will cover in the next video. Thank you very much. Keep with me and give your valuable time too. Thank you very much.